this average part 2. You must be remembering in the part 1, we have talked about the basics, the introduction, the importance of averages. But in today's part, we will be talking about two important things. One, what is this deviation method and how to use it? How would it reduce my effort of calculation? And also the weighted average, which is another very important part of averages and very useful for profit loss, for time and work, in time speed distance, in many other arithmetic part. Okay, so let's look at the agenda today. The simple agenda, average by deviation method, the point number 1, and second, the concept of weighted average. Okay, so let's look at the first thing. What is this average by deviation method? Let's say we have to calculate the average of these 3, 3, 6 and 1, 7 numbers. How would I get the average of these 7 numbers? I will add all of these numbers and then I divide by 7. That's a one way of doing it. So that's a one way. Right? I'm not going to properly do addition of these numbers and then dividing it by number of numbers. Now, second thing is, by looking at these numbers, let me sense one number which I think can be the estimated average. So let's say by looking at these numbers 371, 375, 374, let's say the average is 375. Actually, I try to take a number which might be one of these numbers or may not be one of these numbers, but I try to pick up a number which is somewhere in the middle among all these numbers. So I know the highest number is 382, then we have 378, 374, 375, then we have some number lesser than 375. So I think that average should be nearby 375. Let's say I take the average as 375. Okay, now look at this very carefully. If you say this number is actually 4 less than this, 363, this number is 12 less than this, 382, this number is plus 7, okay, 375 is same number, 368 is minus 7, okay, 374 is minus 1, 378 is plus 3. So you know the good news. If you look at the deviations from 375, I know what is the deviation. Plus 7 and minus 7 has been cancelled. Okay, minus 4 minus 12 is minus 16, minus 1 minus 17, minus 17 plus 3 is 14. Total deviation is 14. Now tell me, this is a total deviation, right? While we are looking for the average. So whatever is a total deviation, whatever is a total sum of these differences, okay, I will divide it by number of element. So I divide it by 7. So what is the answer? 375 plus 2. So answer is 370. Don't you think? Huh? Take it out. What is this? Minus 14. Be careful. Minus 4, minus 12, minus 1 plus 3. So remember, whenever you are dealing with deviation, you always need to consider the sign. Okay. So overall is minus 14. So basically this is minus 2. So basically this is 373. Be careful, right? So what is this approach? Instead of adding all these dirty numbers, I have imagined a number which I can estimate as an average, and I have taken the deviation from that number. Okay. Now, what if I have estimated that 373 is the average? Let's say it is my choice. Let's see whether my answer would have been changed or not. So 373, this is minus 2, this is minus 10, this is plus 9, okay, this is plus 2, okay, this is minus 2 and 3, minus 5, this is plus 1, and this is plus 5. So I have converted all numbers into plus minus case. Let me see what is the total deviation, changing the color. I can say minus 2 and plus 2 is cancelled, minus 5 and plus 5 is cancelled, 9 and 1 10, and this is minus 10. So what is the total deviation? 0. Divide by number of numbers, that is 373. So is your answer change? It is definitely same. So remember, whatever is my assumed average, whatever is I can perceive as an average, if I take a deviation from that average and divide by number of numbers, your answer won't change. Okay. And the one important thing that we have learned here, if the final average is equal to assumed average, the total deviation should be. So this is the formula, guys. Average is assumed average or initial average plus total deviation upon n. I have told you if your assumed average, right, or average that you have assumed is equal to the actual average. If these two are equal, right, what does it mean? The total deviation should be 0. I've shown you the example also in the previous slide. If assumed average is actually the average, the total deviation will be 0. Let's look at this through an example. Mean weight of 6 members is 56. The individual weight of 5 of them is given. Find the weight of 6 members. So one approach is I will add 52 plus 57 plus 55 plus 60 plus 55 plus the 6th member is equal to 56 into 6, average into number. I can simplify this and get my answer. No doubt it can be done. Okay. What can be the other way of doing it, guys? The other way of doing it is very simple. That is, you will take deviation from 56. It is a final average. I have told you if final average, right, is actually the assumed average and I am taking deviation from the assumed average or the final average. I have told you this. What is the case? The total deviation should be 0. Clear? So let's look at the deviation now. 52 is minus 4. 57 is plus 1. 55 is minus 1. 60 is plus 4. Clear? And 55 is again minus 1. Can I say the total deviation should be 0? That means this minus 1 plus 1 already cancelled. Can I say if I have to nullify the overall deviation, if I have a minus 1 here, I should have a plus 1. And this plus 1 should be the deviation for the 6th number. Can I say the 6th number should be what? 56, the assumed average plus 1. So what is your answer? 50. Isn't it clear? Straightforward. No calculations. Can be done very easily. 57 is the answer. Okay. So I have told you the two approach. One is a conventional one. Another is a deviation one. Look at this now. A group of 35 students with average marks 83. The new average marks of the group of student, if a student of marks 89 joins the group, I can very well do it. I can say 83 average into number 35 plus the new student, let's say X. Now the number of students are 36, 35 plus 1 and the average marks is 89. Oh, the average marks is A. Clear? So I can get the new average. I repeat. I says average into number plus new student is average into 36. What is it new student? We know this already. What is this new student? 89. Write it 89. Clear? That's the one way of doing it. I can answer the question by this method. Now, let me show you the another method. You know that initial average is 83. So initial average is 83. Done? Plus. If this person is joining the class, what is the deviation? 89 minus 83. The deviation is 89 minus 83. Clear? Divide by. Tell me after joining how many people are there? 35 was there. But once you consider 89 as a part of group, number of member will be 36. So answer is 83 1 by 6. 6 by 36 1 by 6. Don't you think this method is a faster one? What did I do? Initial average plus total deviation by number of element. Obviously, I always consider the new number of element. Okay. Now, let's say this case was a student of marks. A student of marks 89 has left. Instead of joining, had it been left. So basically, if it is leaving, I will say 83 minus 89. If he is joining, I will say 89 minus 83. So initially it is 83. The change is 83 minus 89. He is leaving now. So 83 minus 89. He is joining, 89 minus 83. Clear? Divide by number of element in the group is now 34. So had it been a case of left, I will divide by 34 because number of member now left is 34, and I would use 83 minus 89, average minus the person leaving. Had it been joining case, it is average. No, it is person minus average. He is joining, so he is on the plus side. He is leaving, so he is on the minus. Simple. Let's look at this another time. So this time a person of marks, a person with marks 66 is leaving the group. So basically what I have told you, initial average is 83. Clear? The person is leaving, so it is 83 minus 66. Divide by, what is the number of people in the group after he has left? 34. So it is 83 plus 83 minus 66, it is 66 plus 7 is 73, 17. 17 by 34. So what is it? 83.5. One approach. Let's say you are not comfortable with this. You want to do the traditional one. You can say 83 is the average into number of people minus 66 because he is leaving, going out is. The new average, I don't know. New number of member. I can solve this and get the value of A from here. It will also come same. I leave the calculation for you. That is 83.5. So are you understanding? We can apply the deviation method here again. Look at this. A group of 43 students with average marks 57. What is the new average marks of the group of the student if? Okay. We have a blank after if. That means something is there. That is. A group of 43 students with average marks 57, right? What is the new average marks of the group of student if a student with average marks 68 joins? Can I directly say if a rich person, he is comparatively rich with the average from the average? So I can say this 68 is definitely creating a surplus. What is the surplus? 57, 68, surplus is 11. The initial average is 57. Surplus is 11, divide by. What is the number of people in the group now? 44. I hope this is clear. Let's say you are not able to think this way, that what is the rich, what is the poor. You can say 68 is joining. So it is 68 minus average. Had it been leaving, it is 57 minus 68. Understood? Let's look at the another scenario. A marks with 35 joins. So if I say a marks with 35 joins, can I say he is comparatively poor? What I mean with poor, less than the average. So average should diminish, average should decrease. The initial average is 57. What is a deficiency? 35, 57. Deficiency is 22. Okay, so it is minus 22. Divide by, how many people after one person have joined? 44. That can be done. If you're not finding this rich or poor kind of thought process comfortable, you can say why this is minus 22, because it is 35 minus 57. Are you getting my point? But gradually you have to train yourself so that this particular thing become very comfortable, right? I am erasing, okay, let it be. I'm not erasing it. Let's take it forward now. And let's look at the another scenario. A student with mark 78 leave. So tell me, this 78% is poor or rich in comparison to the original average? This is rich. Imagine a case that a richer person leaving the group. It is like from your class, the highest scorer is leaving the class. What will happen? Obviously, the average will decrease. So let's say how the average will decrease. Initially, the average is 57. What is the loss? 78 and 57. What is the loss, guys? 57, 78, is it 20? 21. What is the loss? 21. So minus 21. Divide by, what is the number of people in the group now? He has left 42. Got it right? One way. This is a logical thought process. You say, no sir, I am not comfortable with this logical thinking. I want a mathematical rule for it. Okay, Jatin sir is here, no worry. He is leaving, so it is minus 78 from 50. Simple. If he is joining, it is 78 minus 57. He is leaving, it is 57 minus 78. Otherwise, my suggestion is develop this common sense. It will help you. Okay, tell me if this 51, he is the lowest scorer, maybe he is less than the average. He might be the lowest scorer. So imagine it like from your class, the most stupid, me, the most stupid, the duffer most student is leaving the class. What will happen? The average marks will increase. That's what I'm saying. So I say 57. What is the benefit of this? Plus, what is plus? 51, 57 plus 6 divide by 42. Let's say again, you say, no sir, I am not in that way comfortable. So you say, since he is leaving, right? You can say he is leaving out. So it is 57 minus 51. What is it? Plus 6. Choice is yours. If someone is joining, you can say that number minus average is a deviation. If someone is leaving, average minus that number is a deviation. Or you can handle the rich versus poor. It's completely your choice. What's the way you want to think? Clear? Perfect. Can we look at this question now? Average weight of all the student in a class is 48. I don't know how many student. A teacher of weight 73 kilogram had joined the class. Okay. The new average weight of all the student and the teacher will increase by 0.5. Okay. So I can say it like 48 is the average into number of student plus a 78 kilogram teacher is joining. So now the average is 48.5, clear, and number of member is n plus 1. So this is a method number 1. We can definitely do it. No one can stop you applying this method, and maybe in some cases I also use it. Okay. Otherwise, tell me what is the right way. I can say final average is 48.5, new average, previous average 48. What is the deviation? 48, 73. He is joining. So it is 73 minus 48. Divide by number of member n plus 1. So basically you bring this 48 here. So it is 0.5 into n plus 1. Okay. Is 73 minus 48. 48 plus 5 is 53. So 25. Clear? What is the value of n? 49. Please check it out. Is this clear? How many people were there initially? 49. Please check it out. 73 minus 48 is 25. Yes. Now, my point is, can I directly jump onto this part? No need to do this. I'm saying we can even cut it down. What is the change in average? 0.5. What is the number of people in the group after joining or leaving? N plus 1. What is the total deviation? 73 minus 48. So we can directly jump onto this without even writing anything. So this is the second approach. It is your choice. What's the way you want to follow? Okay. Let's look at this once again. What is it? I says change in average into number of people after joining. After joining or leaving. This is not the initial number. It is the final number. Is the total deviation. Total deviation would be what? It will be that number minus a, or it can be a minus x. You know the two cases? X minus a if it is a joining case. Clear? If x joins. And a minus x if x. Choice is yours. Perfect. Do it, guys. It should be done without pen and paper. Let me show you. The average height increases by 1, so it is plus 1. Okay. There was 17 students. Teacher is also included. So now there are 18 people. Right. The average was 149. The teacher has been the part of this. So it is x minus 149. So what is the value of x? 149 plus 8, 157 plus 10, 167. That's it. No pen paper needed. You can also do it systematically, right? You can say 17 student average 149 plus the teacher is 18 student into 148. The new average increases by 1. You can also get the value of x from here is 167, but you know the difference. This is quite calculative. This is very, getting my point? It is very important to understand that if I do not develop the deviation method, I will waste lot much time. So this is the first part done. Now let's move on to the concept of weighted average. So what exactly do you mean by weighted average? If you know a little bit about it. Let me start with a simple example. I say this is a theory. One type of average problem involves the weighted average, which is the average of two or more groups that do not have a same number of members, that may or may not have a same number of members, right? So let's say I take a simple example. I say there is a class 7, right? The three sections A, B and C, the average marks of section A, B and C is given. If I ask you what is the average marks of all the three sections combined, can I say this is 36 plus 44 plus 25 by 3? Tell me. 36 plus 44 is 80. 80 and 25, 105 by 3. So can I say this is 35? Tell me. Why? It could have been the case when it is given that all the section has same number of students. If all section has same number of students. Clear? Otherwise we can't do this. So what's the right way of doing? I will tell you this. Just wait. Let me ask you another question. I am still not telling you what is the number of students in each section. My question is, which of the following can be the average marks of all the three sections combined? You remember the part 1 of the average? What I have told you? The final average is always less than the highest. Clear? But more than the lowest. You remember that? So if you look at this, the lowest is 25, highest is 44. In any case, your average must be in the range of 2. Less than 25, not allowed. More than 44, not allowed. Less than 25, not allowed. More than 44, not allowed. So among the answer option, this is the only possibility. This kind of thought process is very important in DI. Sometimes in DI, if you look at the another graph or another set of data, might be possible this information is given there. Might be possible that number of student is given. But without even getting into that information or without even doing anything, I can sense my answer is only 32 from the answer option if answer option are such beautiful options. Now suppose we are still in trouble and now we were given with number of students. Okay, so what's the right way of calculating average? Think about it. You know that the concept of average. What was the concept of average? Average into number is the sum. I cannot simply add the average and divide by number of average. So what is the only option left? I say 36 into 48 is the total marks of the section A student plus 44 into 32 plus 25 into 64. Clear? Divide by. What do you divide by? The total number of student, the weight 48 plus 32 plus 6. That's your answer. But don't you think it's very, very lengthy? So this is a one approach. Now, my point is, if I just see that among this 48, 32 and 64, there is a common number. What is a common number? 16. Clear? If I take 16 out of this, so 16 threes are, 16 twos are, 16 fours are. I can also take the same 16 common upside. I can also take same 16 common upside, right? So this is threes are, this is twos are, this is fours are. What's the benefit? I convert this number of student into the simplest ratio. What is it? 16 threes are, 16 twos are, 16. I converted this into the ratio. It will definitely reduce my calculation time. This will definitely reduce my effort. But if you still want to reduce your effort, what is another approach? Let's assume, I'm changing the color. Let's assume the final average is 36. You remember the deviation method. Final average is 36. What is the deviation of 36 from 36? 0. What is the deviation of 44 from 36? Plus 8. Deviation of 25 from 36? Minus 11. I am not wrong. 25, 11 is 36. Okay. So can I say the total deviation is 0 into 3, weighted, 0 for 3 numbers, similarly 8 for 2 numbers, clear, and minus 11 for 4 numbers, divide by total number 3 plus 2 plus 4. Basically, I have taken double benefit. I have converted the dirty number of student, the big number of student into the simplest numbers. As well as I also have taken the method of deviation here. Okay, so what is it? 11 fours are 44, 44 and 16. So 44 and minus 16, right? So what is it, guys? 28. If I am not wrong, 28 plus 6 is 34 and 10, 44. Can I say this is 36 minus 28? Because bigger number is negative. Divide by 3 plus 2, 5, 4. So approximately, if I look at 9 threes are 27, I can say approximately answer is nearby. So what is the summary? Whenever we are mixing two or more groups, okay, see whether the weights can be converted into simplest ratio. If yes, wonderful. If not, then we have no other choice. See what can be the estimated average. You can take the middle number as an average. So 25, 44, 36. The middle number is 36. I have taken 36 as an average. And I have considered the deviation from 36. Is it necessary to take 36 as an average? No. You can take 44 as an average, 25 as an average. Your answer won't change. Let me summarize what all we have seen. This is a formula. The final average x is W1 x1, W2 x2, W3 x3. What is this W1, W2, W3? This is called weightage. Actually, it can be considered as denominator. For example, I say average marks per student. Per student. So student is the weight. I say rupees per kilogram. So kilogram is the weight. I say chocolates per student. Student is a base. I say teacher per student, right? That is base is students. Kilometer per hour. R is the base denominator. That is a weightage. Okay. Weightage can also be converted into simplest ratio. This is $1 million point and this is $1 trillion point. Deviation method can also be. Okay. I already have told you if all weights are equal, if W1 is equal to W2, then the final average is simple x1 plus x2 by. I hope it is pretty obvious and straightforward. Now, if you look at this question, in a class of 25 boys and 15 girls, the average height of two group of boys and girls, I mean the group of boys and the group of girls, is 150 and 140 respectively. Find the average height of the class. So I will do it in many ways, right? One, I say 25 boys into 150 plus 15 girls into 140, divide by boys and girls 25 plus 15, so one approach. Secondly, by understanding that this is a number of boys and girls, I will convert this into the ratio. This is 5 5s are 5 3s are, right? So I can say this is now 150 into 5 plus 140 into 3, clear, upon 5 plus 3, done, no doubt. Both the ways we can get the answer, 750 and 420. 750 and 420, 750 and 420, it is 1170, 1170 upon 8. Yeah. So it seems answer is none of these. 150 into 5 and 140 into 3, 750 and 420, yes, clear. What can be the other way now? The other way is I first of all convert 25 boys and 15 girls into the ratio. So I convert the weightage into the ratio. Second thing, I will consider the final average, let's say, as 140. It's always better to take the smaller number so that additions are there. Clear? If you take 140 as an average, let me change the color. What is the deviation here? Plus 10. So this plus 10 into 5. All of you divide by how much you divide? 5 plus 3, 8 or only 5? Divide by total. It is 5 plus 3. Clear? Because at the end in the group there are 8 people. If I am saying 5 boys, 3 girls, there are 8 people. So 140 plus 50 by 8. If you look at this 50 by 8, it is 6.25. So 146.25. So according to this, the answer is 146.2. No doubt about it. Now tell me, if I do not do anything, let's talk about if answer options are given there, and I have just read the story. When I read the story, I was like, okay, one group has an average 150, one group has an average 140. So if the two groups, one is 140, one is 180, 150, if you take an average of this, can I say that average must be between 150 and 140? If you look at the answer option, this, and this all discarded. Your answer can be there, option E, without writing anything on paper. Very much possible, right? That's what my point. So I have told you that whenever we are thinking about average must be between the two. Would it happen in exam? Yes, definitely. That's what I am telling you this. Okay. Let's look at this in any other example, if we have any other example. Okay, this is another question. In a class of 25 students, they have took a sign test. 10 students had an average score of 80 and the other student, that means remaining 15 students, had an average score of 60. Although the numbers are very straightforward, but I am sure that answer must be between 60 and 80. I always make a habit of doing this now onward. You remember the previous example? So 60, 80. Unfortunately, all options are in that range. No help. Let's do it. I say 10 student has an average of 80. Remaining 15 student has an average of 60. Divide by 10 plus 15. So 800 and 900, 1700 by 25. You remember the fast calculation tricks? 25 is nothing but 100 by, so answer is 60. Many students can ask me, sir, this time you did not use the deviation method. This time you did not convert this 10 and 15 into the ratio. Because the calculation was straightforward. No need to do this. Don't you think so? That's what my point. Let's say you want to use this. Let's say you want to use a deviation method. Let's do it. You know, out of 25, 10 is student, 15 is student. So converting this into the ratio. Clear? Assuming the average is 60. Clear? Yes. So look at this. If this number is 60, deviation is nothing. 80 is how much more? Plus 20. So plus 20 into 2 number of student. Divide by total. What is total? 5. So it is 60 plus 8. Although in this question, the information were very straightforward. The numbers were beautiful numbers. So I did not bother to, convert this into ratio and applying deviation method. But otherwise we can do it. Answer is 6. So I think we have discussed both the things that I have promised. Okay. And that's all about the average. We'll see you in the other videos. Primarily, the next video would be mixtures and alligation. Bye bye guys. Thank you.